So less than half.
I have not been keeping track, but I didn't notice a lot of those go by. A lot of, Chem 108, a lot of psychology, a lot of the
What?
less preferred
Chemistry.
gen ed options. So yeah, other than that, I probably shouldn't, give out the specifics, but I don't recall lots, Zane. So
No, it's okay. I'm failing them all anyway, so it doesn't matter whether they're taking it for a grade or not. Just kidding. All the people that are currently in that class are thinking about taking that class. It's really fun when your post office loves you. So sorry, Luke and Zoo. So, all right. So, yep, if everybody's here, then Rachel, we'll turn it over to you to walk us through your portfolio.
Okay. Well, I'm Rachel Bibbey, and I am a creative technologies and biology double major. A little bit about me. I wanted to start with my work background at Berry, which is represented by those middle column of pictures. I have been a lab assistant at Hackberry Lab for 3 years, as well as being a first-year mentor for 3 years for both engineering and creative technologies classes. And then my other job is in BITS, which is the IT service at Berry, and I have worked my way up over 4 years to being the help desk student director. My favorite kind of hobby that I did at Berry was being on the track and field team. I was a thrower for 3 years for the school, and that'll show itself in some of my work later on. My two of the biggest impacts Berry also had on me was being able to do 2 study abroads. My first one was with my biology class in Roatan, Honduras, where we built these coral trees and hung them in the water column to help staghorn coral growth and then replace them back into their natural habitat once they were big enough. And my other study abroad was for CRT in Norway, where we developed different technologies to help teach concepts in an elementary school over there. My theme throughout this presentation will be communicating abstract concepts through projects that yield quantifiable results. And what I kind of mean by this is that I wanted to take either things that you can't see or concepts that you can just like feel and don't have necessarily results unless technology is attached to them, and bring that data so that it can be analyzed by people or just seen instead of felt. My first one that I want to go into is called Impact. This was done as my first big project in CRT, and the kind of problem that I was having is not being able to have physical information or data to look at while I was throwing. It was just kind of based off how I was feeling about the throw and what I thought was changing or improving from day to day. Now, this technology is able to track the position and speed that your arm is in throughout the technique. So it uses an Arduino matched with a gyroscope and accelerometer to track that data. But a Bluetooth sensor was also attached to transmit this data back to my computer at the same time as a video recording is watching the user interact with this. It looks kind of like this. Here are 2 examples of my user testing. So the result of this project is this graph that shows all of these colored lines that you guys see, but each of those colored lines stands for a different axis on the gyroscope or the accelerometer. So it's like showing you what position you're moving forward into or like how fast you're moving. So there is a key that correlates all of these colors to actual values. Now, looking at this chart that's on the right, you can see that every time he would throw the ball, you would get a spike in these red and blue lines, and that would show every time that he would have acceleration and move forward in that X direction. Now I was using these to compare throws over time, so you can see if you like for me, I wanted to move faster, so you can track the changes in these graphs to see if you actually are moving faster over time, and you don't have to just rely on feeling like you're getting better. You can see the changes of each throw when you compare these over time. My second project that I want to talk about is these ghosts. This was my technology that I brought to Norway. So the problem that I wanted to address was the abstract kind of feeling of circuit design and current moving through a system without being able to see it. So doing these projects with younger students, I wanted to use fabrics and technology that was more familiar to them than a traditional breadboard and jumper wire type of circuit. So using this conductive thread, it shows the students kind of the path that the current will have to take to get all the way through, and it also will show them a demonstration of when a circuit is not connected and that it wouldn't work, and then when it is connected, the eyes will light up. And to do this, we handed all the students the components they would need. These PCBs that we designed have either an LED on them or a battery pack. They get both. And so once they lay all these components on, they would use that conductive thread to connect all of the components so that we were able to teach them that you have to connect all of these in order to get the current to flow all the way through. And so that was kind of the way that we were showing them what a complete circuit looks like, instead of just having a wire jump from one place to the next until you get from start to finish. And so some of the complications with this were originally being designed for an 8th grade class, but then teaching it to an elementary school. We struggled a little bit with the sewing aspect, which could have been a whole class in itself. So that was a struggle for them. And then also these holes were designed this large so that the thread could be wrapped around multiple times to make a strong connection. And so some of the problems that came up are when kids were struggling with sewing, they wouldn't have a strong connection, or if they skipped a hole, when they went to go complete the circuit, it wouldn't show up. So when we went over and helped the kids learn how to complete the circuit and go from one section to the next, when the eyes finally lit up, the kids were so happy, and like they could see that they were actually completing this, and it wasn't just like, you know, connecting one wire to another, like they had traced this path themselves. The third project I want to talk about is Kitten Keeper. This was our intermediate design studio class, and the goal here was to create an incubator for premature kittens. And so all the requirements listed on the screen had to be considered and implemented, but the main one I want to focus on is temperature and humidity. And so the problem specifically with this was that the staff needed to know the conditions of the enclosure, what the temperature was and the humidity for the kittens at all times. And so without having data being relayed back to you, you don't necessarily know what it is. You can't just feel a temperature and automatically know what it is unless you're amazing. So to do this, we designed two different parts of the structure. The first is the PCB that was implemented. Now this controls and relays back the temperature and humidity, which is sensed from within the enclosure. And I circled the sensor in the red on the first image. This is supposed to be the hottest spot of the enclosure so that we know what the temperature is, so that no kittens would get hurt or burned if they were migrating toward that hot spot. And so for the staff, the important part is getting back that information, which is shown on the LCD screen of the PCB at all times. And they can change that temperature or humidity with the red and blue buttons shown on the PCB. So if they need to raise the temperature, they can click up on the red dots, and then they can watch as the temperature climbs. The other important part of this process was creating the enclosure out of acrylic. This not only helped with our requirement of being easy to clean, but it also helped with the ability to see if the kittens were in distress. If they were maybe moving away from the heat, the staff could see if it was too hot, and if they were all crowded around, maybe they needed to turn the temperature up, or if something went wrong, they could see the kittens walking around. In traditional structures, they are enclosed in plastic on 3 sides, and you have to look through the front. So this gives them, the staff, the ability to see the kittens at all times and let them know if something is wrong without having to like guess if something's happening. This last one is called the Santa Timer, and this is my senior capstone class project. And so the main point of this was to teach children how to estimate a 20-second time period. Time is something that when you're trying to figure it out internally can differ from person to person, how fast you count, the way that you do it. And unless you're looking at a clock, most people will have a different time, a different perception of 20 seconds. And so this was specifically brought about to help elementary, kindergarten students learn how to wash their hands for this 20-second time period, because that's the standard. And so to do that, we created a feedback system so that each time you're interacting and guessing at what a 20-second time period is, you would get validation if you were correct or not. So I want to walk you through the process a little bit. So we're going to start in the top left, and it starts with the soap dispenser. When you go to get soap, there's a capacitive touch sensor in the handle, and it will activate a timer on the PCB run by the Teensy. And at this point, the LCD screen in the enclosure will produce this timer started screen. At this point, all of the students should start scrubbing their hands for what they believe is their 20 seconds. When they're done with that, they will run their hands back under the soap dispenser to stop the timer. When the timer stops, the LCD screen will change to represent that and tell them how long they wash their hands. At this point, the students will rinse and then dry their hands while the receipt is being printed. And then when they're done with that, they should be able to take the receipt. Now, the goal of this is also to track progress over time so that you can get a better idea of what your representation of time is. So during my user testing, I had them use this machine at the start of a day, and then I recorded the results through the end of the day. And each of the users improved their perception of 20 seconds by the end of the day, and were within 1 second of 20. So it helps them have a feedback to know what 20 seconds actually is, instead of just guessing if you're washing your hands for the correct amount of time. My last thing I want to talk about is my future plans. I have accepted a job as a quality engineer at Lockheed Martin. I got this kind of through my internship from last summer, where I was working on user interface design for the work instructions that go out on the production floor. And so after my presentation of my solution for that project, they offered me to come back as a quality engineer. And for that part of my job, I will be looking at the engineering instructions and requirements, as well as the government requirements and standards, and making sure that all products produced on the floor meet both of those standards before they're shipped out of the facility to be implemented into further designs. And so I start that as soon as I graduate, kind of on June 1st. But I have another goal once I get there of going and getting my master's in human factor engineering, because I want to move into that branch of the company where they take a little bit of a different approach, and I would focus more on the ergonomic design and layout of what the pilots interact with. I would specifically want to work with space design or airplane design. So it would be kind of looking at the way that the panels are laid out, or the way that they sit in their seats, or the way that their chairs are designed, and more focusing on how to improve that experience for each of the pilots.